Hi, welcome to my channel and session 2 of ASCE 722. Today we will talk about different building types and their associated risk categories according to ASCE 7 and IBC 2021. At the end of this session, we will learn how to put a specific building in a correct building risk category. Don't forget to check my Instagram and Telegram channel at ASCE7_22 for more contents. You can download the PDF files of the classes by visiting Telegram channel too. At the beginning of this video, we will have a review of the previous session that we talked about basic definitions and requirements. As you know, different standards such as ACI 318 and AISC 316 use the limited states method to design structures. Limited states are conditions beyond which a structure or member becomes unfit for intended function that we call its serviceability limited state, or to be unsafe that is called a stress limited state. Then we introduced two applicable procedures in order to provide limited states in our designs: allowable stress design or ASD and load and resistance factor design or LRFD. About these two procedures, for example, their fundamental equations, the components in those equations like nominal stress, allowable stress, factor of safety, factored loads, resistance factor, design strengths, and of course their basic differences we talked in last session completely, and you can refer to it for more information, and I put its link herein. After that, I said that there is also another procedure which is applicable for our structural designs for some special buildings and circumstances, that is named performance-based design. Moreover, ASCE obligates us to provide some basic requirements in all of our designs, such as strength and stiffness, serviceability, functionality, and so on, that I have listed them here. And finally, we saw that structural integrity is another crucial factor in every structure, and we should care about them according to ASCE and other standards to provide its different aspects that I have listed them herein too. As I said at the beginning of this session, we have different kinds of buildings and structures with different risk categories. Buildings and other structures shall be classified based on the risk to human life, health, and welfare associated with their damage or failure by nature of their occupancy or use, according to Table 1.5-1. As you see, ASCE has divided all types of buildings and structures in 4 separate categories, and we will talk about them in this slide completely. First of all, we have risk category number 1. Risk category 1 structures generally encompass buildings and structures that normally are unoccupied and that would result in negligible risk to the public should they fail. Structures typically classified in this category have included barns, storage shelters, gatehouses, and similar small structures. Before telling you about the characteristics of risk category 2 and 3, I prefer to talk about the fourth one. Risk category 5 has traditionally included structures the failure of which would inhibit the availability of essential community services necessary to cope with an emergency situation. Ancillary structures required for the operation of risk category 4 facilities during an emergency also are included in this category. In addition to essential facilities, building and other structures containing extremely hazardous materials have been added to risk category 4. These buildings contain sufficient quantities of highly toxic substances where the quantity of the material exceeds a threshold quantity established by the authority having jurisdiction and is sufficient to pose a threat to the public if released. Buildings and structures typically grouped in risk 4 include hospitals, police stations, fire stations, emergency communication centers, and buildings with similar uses. After risk category 4, I want to talk about the third category in this table. In this category, there are buildings and other structures that we can't put them on risk category 4, but the failure of them would cause a substantial economic impact and or mass disruption of day-to-day civilian life in the event of failure. Risk category 3 includes buildings and structures that house a large number of persons in one place, such as theaters, lecture halls, and similar assembly uses, and buildings with persons having limited mobility or ability to escape to a safe haven in the event of failure, including elementary schools, prisons, and small healthcare facilities. This category has also included structures associated with utilities required to protect the health and safety of a community, including power generating stations and water treatment and sewage treatment plants. It has also included structures housing hazardous substances such as explosive or toxins, which, if released in quantity, could endanger the surrounding communities, such as structures in petrochemical process facilities containing large quantities of hydrogen sulfide, H2S, or ammonia. As I said, we can put these structures in this category. Finally, risk category 2 includes the vast majority of structures, including most residential, commercial, and industrial buildings, and has historically been considered to contain all those buildings and structures not specifically classified as conforming to another category. Let's talk about some points about risk categorization. First of all, it is so obvious that when the building code or other reference standard specifies an occupancy category, the risk category shall not be taken as lower than the occupancy category specified therein. Secondly, where a building or a structure is occupied by two or more occupancies not included in the same risk category, it shall be assigned the classification of the highest risk category corresponding to the various occupancies. Thirdly, assignment of a building or a structure to multiple risk categories based on the type of load condition being evaluated, for example, snow or seismic, shall be permitted. For instance, there are circumstances when a building or other structure should appropriately be designed for wind loads associated with risk categories greater than 2, but would be penalized unnecessarily if designed for seismic loads at the same risk category. An example would be a designated post-hurricane recovery shelter in a low seismic area. The building would be classified in risk category 4 for wind design and in risk category 2 for seismic design. The fourth point is this: where buildings or other structures are divided into portions with independent structural systems, the classification for each portion shall be permitted to be determined independently. Where building systems such as required egress, HVAC, or electrical power for a portion with a higher risk category pass through or depend on other portions of the building or other structure having a lower risk category, those portions shall be assigned to the lower risk category. And finally, buildings and other structures containing toxic, highly toxic, or explosive substances are permitted to be classified as risk category 2 structures if it can be demonstrated to the satisfaction of the authority having jurisdiction by a hazard assessment as part of an overall risk management plan (RMP) that a release of a toxic, highly toxic, or explosive substances is not sufficient to pose a threat to the public. Now I have a question. What do you think about building categorization in the past? How do we use to separate different buildings according to risk categories? For many years, ASCE standard used the term occupancy category, as have the building codes. However, the term occupancy as used by the building codes relates primarily to issues associated with fire and life safety protection, as opposed to the risk associated with structural failure. The term risk category was adopted in place of the older occupancy category term in the 2010 edition of the standard to distinguish between these two considerations. The criteria that have historically been used to assign individual building and structures to occupancy categories have not been consistent and sometimes have been based on considerations that are more appropriate to fire and life safety than to structural failure. For example, university buildings housing more than a few hundred students have been placed into a higher risk category than office buildings housing the same number of persons. A rational basis should be used to determine the risk category for structural design, which is primarily based on the number of persons whose lives would be endangered or whose welfare would be affected in the event of failure. Figure C1.5-1 on page 492 of ASCE 7 illustrates this concept. Lives at risk pertains to the number of people at serious risk of life loss given a structural failure. The risk category classification is not the same as the building code occupancy capacity, which is mostly based on risk to life from fire. From this concept, emergency recovery facilities that serve large populations, even though the structure might shelter relatively few people, for example, fire stations, are moved into the higher risk categories. For more detailed information about occupancy risk categories, you can refer to Chapter 3 and 16 of IBC 2021 code. Here I have brought table 1604.5 from Chapter 16. As you see in this table, there are much more information and examples about different risk categories, and I have highlighted some of them. Moreover, there are some groups that they belong to different risk categories in this slide. I have listed different building risk categories according to Chapter 3 of IBC. For more details, you'd better to refer to this standard and read more about them. Thanks for watching this video till the end. Don't forget to subscribe to my channel for more contents and give me a thumbs up if you like this video. Join to my Instagram and Telegram channel too, so you can download the PDF files of the class. For the next session, I will talk about load importance factor and its importance in our designs. If you have time, I have left its link here now. Click and watch it. Thanks for your energetic comments and bye.